What if the forces that govern our universe were once in the distant past indistinguishable from one another? This is the central question posed by the Grand Unified Theory, or GUT, a concept that has fascinated physicists for decades. The Grand Unified Theory is a model in particle physics that suggests the electromagnetic, weak, and strong forces were not always separate as we know them today. Instead, these forces, which comprise the three-gauge interactions of the Standard Model, were unified into a single force at high energies. Imagine a time in the early universe, a grand unification epoch, where these fundamental forces were not distinct, but part of a singular unified force. The idea of this unification is not without precedent. Experiments have shown that at high energy, the electromagnetic interaction and weak interaction combine into a single electro-weak interaction. GUT models take this a step further, predicting that at even higher energy, the strong and electro-weak interactions will unify into one electronuclear interaction. However, unifying gravity with the electronuclear interaction would create a more comprehensive theory of everything, making GUTs often seen as an intermediate step towards this ultimate goal. The particles predicted by GUT models are expected to have extremely high masses, well beyond the reach of any foreseen particle collider experiments. Therefore, these particles will likely remain unobserved directly, but the effects of grand unification might be detected through indirect observations such as proton decay, electric dipole moments of elementary particles, or the properties of neutrinos. Some GUTs even predict the existence of magnetic monopoles. However, it's important to note that while GUTs might seem to simplify the complexities present in the Standard Model, realistic models remain complicated. They often need to introduce additional fields and interactions, or even additional dimensions of space, to reproduce observed Fermion masses and mixing angles. This complexity, along with the lack of any observed effect of grand unification so far, has meant that there is no generally accepted GUT model. The first true GUT, based on the simple Lie group SU5, was proposed by Howard Gorgey and Sheldon Glashow in 1974. This model was preceded by the semi-simple Lie algebra Padi-Salam model, which pioneered the idea to unify gauge interactions. In conclusion, the Grand Unified Theory seeks to unify the fundamental forces of our universe into a single force, providing a simpler explanation for the complexities of the Standard Model. However, the theory remains a work in progress, and while it offers fascinating possibilities, it's still a stepping stone on the path to a comprehensive theory of everything. As scientists continue to probe the mysteries of the universe, the Grand Unified Theory remains a tantalizing hint of the deep connections that underlie the world as we know it.